Alright, second video will continue. Okay. A medium through which light passes is called, okay, a medium through which light cannot pass. Okay, I'm sorry, cannot pass is called opaque medium. Alright, so from opaque, light doesn't passes. From transparent, the light passes. The sun is a dash source of light, so it is a natural source of light. Okay, we have not created it, it is naturally available to us. Light gives us the sensation of vision. Okay, we can see things because of light. Okay, name the class to which the following lever belongs. Okay, a pair of plier. So plier, it belongs to class 1 lever. Class of plier is something that looks like this. I'm so sorry for the diagram. Okay, so here you put something, whatever you have to use this. Okay, here you will put the effort and here the fulcrum. So where the fulcrum is in between the load and the effort, that is a class 1 lever. So this is a class 1 lever. Okay, a nutcracker would be a class 2 lever because load is in between the fulcrum and the effort. Okay, name the class to which the following lever belongs. Okay, a beam balance is again the fulcrum is in between, so it's a class 1 lever. Okay, now on all this I've done videos, so please go through those videos if you have any doubts. Okay, name the class to which the following lever belongs. Okay, a wheelbarrow, it is class 2 lever. Again, the load is in between the fulcrum and the effort. Name the, okay, a lemon squeezer, again a class 2 lever. Lemon you put it in between, okay, where the load is in between, so it's a class 2 lever. A pair of sugar tongs, it's a class 3 lever because the effort is in between fulcrum and the load. Okay, seesaw, class 1 lever, fulcrum is in between load and the effort. A, a crowbar, it's a class 1 lever. Again, the fulcrum is in between. Name, okay. And oar rowing a boat, again, it's a class 1 lever. So it's basically, okay, so a boat, you have something like this. Okay, so you hold the handle, you put the effort over here. It is locked to something over here, and then the machine does the work. So this part, this becomes a fulcrum, this is your effort, and this is the load. So fulcrum is in between, hence it's a class 1 lever. In class 2 lever, dash is in between, so in class 2 lever, load is in between. Okay, give an example of a class 1 lever. So just remember, in class 1 lever, you have all the three mechanical advantages: more than 1, equal to 1, and less than 1. So equal in seesaw, it is equal to 1. In plier, it is more than 1, and in scissor, it is less than 1. So answer is plier over here, it is more than 1. So mechanical advantage is basically effort arm upon load arm. So in plier, the effort arm is more, okay, than the load arm. So this is the load arm and this is the effort arm. Okay. So effort arm would always be a greater number. Suppose this is 2, so this will be 1. So mechanical advantage will always be greater than 1. So it is in plier. In case of scissor, it is other way around. Okay, so I think there's a question, so we'll discuss about it. In class 1 lever, dash is in middle. So in class 1 lever, fulcrum is in middle. Give one example of class 1 lever where the mechanical advantage is less than 1. Then again over here, less than 1, it is a scissor. In scissor, okay, so this part over here, it is smaller as compared to this part. So this is the load arm. Load arm is more, and the effort arm is this effort arm, and this is the fulcrum. So effort arm is smaller than the load arm. Hence, mechanical advantage is effort arm upon load arm. Effort arm is less. So suppose this is 1 and load arm, suppose it is 2. So answer will come as 0.5. So it is less than 1, 0.5. Hence mechanical advantage is less than 1. Okay. So that is in the case of scissor. In class 1 lever, scissor. Okay. In class 3 lever, dash is in middle. So in class 3 lever, the effort is in middle. For example, a forcep. So forcep is something like this. Okay, you hold it over here, or sugar tongs. So you pick the sugar, you keep it over here. You put your effort over here. The fulcrum is over here. So what is in the middle? Your effort is in middle. Okay. Give one example of class 1 lever where the mechanical advantage is equal to 1. That is seesaw. In seesaw, the mechanical advantage is equal to 1 because the load arm and the effort arm both are equal. So there is something over here. Fulcrum. This is the load arm, this is the effort arm. This both will be same. Okay. Okay. Name the class to which the following lever belongs. Now this is a plier. So plier belongs since the fulcrum is in between the load and the effort. This is a class 1 lever. So this is a class 1 lever. Okay. Again, this is a crowbar. So crowbar, it is again a class 1 lever. So you are putting your effort over here. Effort is over here. This is the load, and this is the fulcrum over here. The support that you are taking, that is the fulcrum. Okay. So where the fulcrum is in between, it's a class 1 lever. Okay, name the class to which the following lever. This is a lemon squeezer. So you put the lemon over here. So that becomes your load. Here is your effort, and this is your fulcrum. Okay. So when the load is in between, it's a class 2 lever. So it's a class 2 lever. Now sugar tong. Here you put your effort. Here is the load, and this is the fulcrum. So when the effort is in between, it becomes class 3 lever. So this is a class 3 lever. Okay. A kilogram force. Okay, kilogram force, it's a unit of weight. Weight is nothing but force, and Newton itself is a unit. Mass and speed, no. So kilogram force is for weight. Okay, meter ruler is used for measure length. Okay, so you use ruler to measure length. SI unit of area, meter square. We have already discussed this. So it is getting repeated. So consider it to be more important. Okay, static friction is more than both sliding friction and rolling friction. Okay, it is difficult to open an ink bottle with a greasy or oily hands because it lacks friction. Okay, because there is no friction. So lack of friction. Okay, it becomes slippery and we can't open it. Interval between two instances. That is the definition of time. Length of a housing plot. So how you measure a housing plot? By using measuring tape. Okay, and the SI unit of force is Newton. Okay, this was also discussed. All right, we'll stop over here. Thank you.